Hey guys, it's Steve on the Guru Brew. Today's show is about, that's it, mice. Actually, we're going to be talking about optical mice. The day of the ball mouse is over for good reason. We'll talk about these reasons. We'll discover some new things about mice. And we'll learn how they work. I'll open one up and show you some things I bet you didn't know about mice. Well, if you're watching this and you're still using a mouse with a roller ball in it, you really don't know what you're missing. Optical mice have been around since early 2000, and really they were introduced in the 80s but didn't become mainstream available until early 2000. There's major differences that you would know about if you own an optical mouse. First of all, there's no moving parts, and you don't have to clean the ball on the mouse. You know, typically you'd have to take this ball out of the mouse, clean it with alcohol, and then all the surfaces inside, and keep this working properly. Whereas an optical mouse, you just have to make sure that there's no debris inside this window. And that generally doesn't happen because this rides slightly above the surface. There's an LED that's inside the optical mouse that shines down onto the surface and keeps track of the position. More about that in detail in just a moment. Some of the other differences is there's better tracking and higher rates of resolution, whereas a mouse ball, a lot of times you'd have to push it along, and sometimes it wouldn't move, and then you slam it on the desk a couple times, and you just don't have that problem with the opticals. They're much more precise. So let's go ahead and talk about how these work, and then we're going to open one up and get a further understanding of it. Well, like I said, enough of the bald mouse. This is really the way to go. An optical mouse is pretty simple, really, even though it's not at the same time. Let's flip it over and take a look. This window right here is actually a small camera with a LED that illuminates what it's looking at. When you plug a USB mouse into your computer, the power lights in the LED, and we'll get a look at that here when we take this apart. But the LED is usually red in color, and it lights up the surface, which would be whatever you're using for the base of this mouse. And then this is actually a small camera inside this window. It's mounted on a chip, and there is a magnifying glass that helps to make it even larger, and it examines the surface, and it can detect if it's moving because it takes more than 1,000 pictures a second. Most optical mice go anywhere from 1,000 to 2,000 frames per second. So what it does, basically, it takes a picture, and then it takes another picture, and then it compares the two, and if there's movement, it counts the distance between the old picture and the new picture to determine how far and how fast it's traveled. So basically, there is a little tiny camera in here. And in theory, we could actually turn this into a camera and take a picture with it. And we're going to actually try to hack this one and see if we can't do that and see what kind of images this will produce. There's two main types of mice. There's the cheaper LED ones, such as this, and there is also laser mice. And the difference is they use a different diode for the measuring device, if you will. They use infrared LED lasers as opposed to just cheap LEDs. The most typical is, of course, the optical mouse, the LED mouse, like this one. And the red is used generally because it's very sensitive to red light rather than other colors. I've seen Blue used too. Blue is also used on Microsoft mice, and they have chips that are specially designed to pick up the UV light of the blue color. So, because this is a camera and it's mounted behind a magnifying glass, it's able to pick up very, very fine detail of a surface, such as this mat. Even on white paper, maybe you wondered how a mouse can pick up on white paper. It actually has such a close view that it can see the fibers inside this paper. Now, I will tell you that I've seen the images that are produced off these cameras, and they're not very high resolution. They're only about 18 by 18 pixels, and that's very grainy, very small. But the resolution speed, like I said, is 1,000 or better to keep track of different movement. So if it can see a blur of a fiber and that fiber moves that much within, a second, this mouse can calculate how long it's taken to get from this frame to this frame and in what direction you're going. So let's bust this open and take a closer look at it and discover how it works exactly. So there's a little sticker here, and underneath this sticker is the only screw that's holding this thing together. This particular mouse, I actually bought it at Big Lots, and it was about $8 or $10 all. Yep, that's it. That's all that's inside one of these. So really, the main part of this whole thing is this IC package right here. And the underside of it has the optical camera, and I'll show that to you in just a moment. This particular chip right here is an A2639B, and it's a 12-pin package, and this particular one handles the USB interface as well as PS2. It handles the 5-volt power supply regulation. It handles all the key support for the 5 micro switches that are on board, and it has 8 DPI, up to 1600 DPI resolution. And so this package handles everything. It handles the tracking as well as, counting pixels and calculating exactly where the mouse is. There's smaller packages that have a separate chip that do your processing, and I have one of those here. I'll show you in just a moment. Let's go ahead and take a look at this one more in detail. This is the actual red LED, and this illuminates the base of what it's looking at, as I had mentioned earlier. Let's pull this out of here. This piece right here serves 2 purposes. It has a really, really strong magnifying glass on here, and I was looking at it on a piece of paper, and it's really close up, super close up, and that's what the camera looks through. And this is actually a light pipe that's built onto this plastic, and that helps to direct the light exactly where it's needed, which is in the path of the camera. Let's flip this over now and get a look at the camera. So there it is, the 12-pin IC package, the little camera, and that's really all there is to it. So the camera looks through this lens. See if we can put this on here backwards. Just like that. The camera looks through the lens, magnifies the base, and the LED light comes through this light pipe, it's called, illuminates, and then sends it back to the chip. The rest of these electronics on here are pretty self-explanatory. Of course, this is the mouse wheel, and it's hooked to an encoder here that measures, how fast and how long you rotate this wheel for your Z-axis. There's also these micro switches There's left and right click as well as mouse click on that. And there's just a few passive components on here that support the input power and the regulation for the LED, and all the processing is actually inside this chip. Let me show you another package that's not quite as smart as this one. Up on my screen here is a data sheet of that little chip, the A2639B, the 12 pin, that contains the little camera, the CMOS camera, as well as the USB control and processing. So it has digital and analog processing on board. And that's how I'm going to hook it up so I can hopefully turn this into a camera. I'm going to try to figure out how to wire off this data plus clock line and the power LED. This design right here is an older mouse that I opened up. This is a Logitech, and it's pretty much the same idea. Here's a little package here. This is an 8-pin package, and that contains the analog camera with the data and clock lines on it. And this package over here does your processing as well as the USB support here. So this is how they used to build them, and this is how they build them now that they've got the all-in-one type packages. I'm going to go ahead and try to hack this one, but I have a feeling I'm going to have to use this one because I think the digital is going to give me a problem, because I'm going to try to read this through USB. Let's go ahead and look at the program that I plan to use to turn this into a little camera so we can see what this looks like visually. To give a better understanding of how an optical mouse works, sometimes it helps to visually see what's happening. I found this web page online, and this guy hooks up his optical mouse and turns it into a camera. And here's the page. I'll put the link in the description, and the credit goes to him for this hack. And I also used the software that he provided. Anyway, he describes on this web page how you can hook up the camera that's inside this board to some wires that go to a modified parallel port. And then using his software, you can actually see images. You can see there's a E right here on a piece of paper, and an S, I think it looks like. It's not high resolution, like I said before. It's very low res, but it's got a very high frame rate, and that's how it works. And then here he is again, scanning a receipt that he had in. And here he describes how to hook up the parallel port and to wire the chip. Now, he has a different chip than I have. I have this 12-pin package, and he's talking about an 8-pin. I'm going to go ahead and try it with the 12-pin first and see if I can do it. If not, I'll resort to the smaller 8-pin. Alright, so I've got this board out of there, and I want to go ahead and wire it up so I can read it through a parallel port. What I've decided to do is use the USB cable that's on it and run the positive voltage to the chip and the negative rail, and then I need the input and output for the clock and the data, and I used the data sheet that I got online, and I identified the 2 points here, and I'm going to go ahead and use the other 2 wires on the USB data cable to hook those up directly. That way I don't have to hook this into a computer to get my 5 volts, and I won't destroy anything if it goes wrong. So this is my hacked mouse. You can see I had to solder a few wires on here. I've got the input output line, my clock, the power, and the ground. And then I had to modify this parallel port. I used a diode, and then hooked up the rest of the pins. I'll put a link in the description of how I hack this. Let's try it out. Okay, so I've been playing around with this board that has the 12-pin optical on it. And I went ahead and soldered the wires on there and hooked it to my parallel port that I put a diode on and stuff like that. And I've been having trouble with it because the digital side, because this is an all-in-one chip, the digital's messing with the analog. I tried to cut a few traces, but it just didn't work. So I went ahead and grabbed the older Logitech mouse that had the 8-pin package on it here. And I was able to get it going, so I'll show you how that looks on the screen. And the reason why this one worked is I could totally disconnect this chip over here and just use the optics from this. So this is the mouse that I'm going to use to do the demonstration. Alright, so I'm going to try to scan this piece of paper with my mouse. Let me put it on a screenshot so you can see it. So it's very sensitive, and if you move it just a tiny bit, if I lift off, it gets very dark because it's not getting much light. I'll put it back down here. So I'll show you how this is hooked up in the back of the computer. So I've just got it temporarily hooked up to my parallel port, and I'm just using a Windows XP machine. And then I've got the USB connected here for my 5 volts. So try it out. So this is a look at the camera through the eye of the mouse, and I've got it on a piece of paper here. And there's not much to look at. It's pretty blurry. You can make out, you know, little lines and stuff like that. And it's grayscale for sure. And really that's all it needs to know what direction it's changing. If I move it really slow, I can almost see what I'm looking at, but not quite. I think I could probably get a better image if I were to play with the lenses or even take it out. But really I don't think it's worth it. I just wanted to give you a quick demonstration of, you know, what it's like to see through the eye of a mouse. And as you can see, it's not much to look at, but it is what it is, and that's all it needs to work properly. So okay, I hope you like that. So that is it for my little discussion on the optical mouse. It really is simple. At the same time, like I said, it's very complicated. The fact that a little piece of plastic that costs $10 can hold a chip that can take pictures up to 1,000, 2,000 times a second, compare those images, and then figure out travel, direction, and speed all from that information is quite amazing, no matter how you look at it. So anyway, I hope you enjoyed this video, and we'll see you again real soon. Bye for now. I got me a mouse.